Okay. Can you hear me? Good. Today it's my first talk, which I'm trying to be not too technical. And the talk is about scale. If you cannot read it, it might be a scaling issue. But actually, the slide is for Steph because he always complains that my fonts are too small. So this time I want to make it for real. So the talk is a tale about scale. I mean, it rhymes, it's good. And scale, it's just sometimes there's terms like types, everyone talks about types, but actually they talk about different things all the time. And the same it happens in scale, especially if you look at LinkedIn or social media. People, or especially technical people, talk about scale, and there's also multiple flavors of having scale or not, or what is needed to be scalable. I showed it to Marcus, but then he said, hey, there's not much technical details in here. So I just changed my slides. I added this one. I try to, because when it comes to scale, there's technical scale and there's something which you will do when you try to do a product. So a technical solution and a product are two very distinct things. And as I happen to have a product which is called AptiveQuid, I presented last year, and maybe some of you know already, we try to not only tell always people what they have to do, but we should do it ourselves the right way. So, and that's how we scale a project. So I'm usually the guy, so I'm involved in all the community and stuff, but I like talking about Faro in practice. So I had multiple talks about deployment scenarios, so how you bring it in action. Because since almost about 20 years, I have projects bringing real Faro products on that still run, even 20-year-old projects. So it's as I had I had to do a lot of Linux and Unix in my life. So this is also an expertise I don't want to do, but I always have to. So. And I like this kind of talks, and I did a little research, and in Faro Days 2015, I did the last one of that sort. Back then it was just about databases, people always like Postgres. From the start you need Postgres and all this stuff. But actually you don't because you have an image. And I was curious myself how far away it was. So just making the. So oops, yeah. So the question is, what is actually scale? When I look in the internet or on LinkedIn, so there is three kinds. So there's one even massive distribution of things spanning the whole globe. Or on the diagram below, there is something like, wow, I got 1.2% more performance because that's, if you're Google, that's a lot. So it's at least 10 salaries a year. And then there's this Netflix tech stack everyone is talking about. So, and what people do is making a simple error saying, Netflix did it, they have success. If I use that tech stack, what might happen? Huh? So, and that's just something, no. So don't stop. So the one thing, all of these, you see all these big diagrams with all the components, they have all something in common because they have nothing to do with the problem you try to solve. Because that's kind of a business model. You try to sell something, and all the technical components, they don't belong. It's about logging, monitoring, everything, but nothing what you want to do. So we try to make it really simple and keeping the focus in developing a project. And we use the CPM model, which you might know, but I don't guess because I just made it up for this presentation. And the CPM model for me, and projects always start like this, is computer, Faro, me. That's all you need to start a project. The good thing about a Faro, because there's code repository, there is persistence, there is an IDE, and it's really lucky condition that the image is all of these. So you don't have to care about all of these if you start a project. Keep focused on what you try to do. And the Smalltalk, Faro, or whatever Smalltalk dialect you use, you know that this is the environment that helps you focusing, solving your problem. and not the problems of anyone else, of everyone else. So, but at one time, so I started, so we have ActiveGrid, a backend system, some sort. I wouldn't call it a product. Yeah. So there is a front end missing. So user wants to use it, people want to use it. So there's something missing. So I'm saying, okay, now it's also kind of scale because you have to scale the team. So it's 100% more people. So if you say it's a second person, it's 100%, and that's a lot. So usually scaling in that regard is really difficult. And before I forgot, most of the credits go to ChatGPT about the images. That's the one thing you can really do good. So maybe the only thing, but that's good. Yeah, so you need, for the system, you need at least two components, front and back end. So as we are in a 2, 3, or 4 tier business, that's the case. So what does change from going from one IDE to two different distinct stuff? Do you lose all the stuff? So you have to scale. So, and then maybe it's more difficult to get it. What we did at the beginning is just sitting in the office. I told it, oh, my IP address is like 192, blah, blah, blah. And then gave it to him, and then he was just developing the front end on my firewall while I was developing. Yeah. And at one point said, I got a 500, which is the HTTP word for unhandled exception. And then say, oh, well, so just switch the sync server to debug mode, true, and then repeat. And then I get a debugger. I'm saying that's an easy mode. And the funny thing about that is we keep doing this for weeks. So the first incarnation, maybe 6 to 8 weeks, we did it like this. So really going, that's the fastest way you can develop a product. It's just like you bump into problems, you solve it immediately. I mean, we all know that that's easy. And then you go really direct, in a direct fight. It's really just a Mortal Kombat image we saw before. And that was really good because the first thing that was usable was done that way. Of course, there's drawbacks if you use like this. It's 2 labs on a network, we call it, and the one which is not good for most is you suffer from DOS attacks, because if I go home, that's a typical denial of service, and that the front end person just like cannot work anymore. So, but that might be another reason to scale up, to saying, okay, that's a good reason, saying, okay, if the back end laptop is closed, the front end can go home as well. So that's not the best condition. So it's time to scale again. This time it's not 100% more, but we need to go in a deployment scale. It's just a different team scale. If you do a product, you need to scale entities, and there's many entities, and deployment is also something, because coming from the 2 laptops on a network, now you need to rent a server on a cloud provider, you need to enter a DNS record, and blah, blah, blah. But then, you cannot shortcut that, but you cannot still go easy and saying, oh, there's a secure copy command on my machine. I just save and quit my image, then I do copy that online to the server, then I log in, and then I just start it. So this is just, it's running, and now even the front end can work when I'm at home sleeping. The one thing you lose is, the good thing when you have 2 laptops is you have the database at your site. So the one thing you're losing now is that the data that accumulates while you're working is lost because you have something installed somewhere else. So, but we did it just at that time, saying there's stun. Sometimes when something persists, we just put the whole thing as stun on the disk, and then when you copy a new image and you start it, not everything is lost. So, but at that point of a project, you can still say, okay, if there's a really big refactoring, and I'm super annoyed to convert all the data, we can scratch it and build it up from new, because it's just for us. And the benefit, as it's in the internet, you can show it to people. And that's something for, maybe that's the biggest advice of all times, is that you should deploy early and show to people early, because feedback is the golden thing in developing a product. Because you do it for users, and if you don't ask them, it might be not what they expect, and you will have trouble selling it. All right. So, but there's also the problem that if you work more, then the database gets bigger. Maybe there is a friend, a family, a colleague, or something which goes in, and then saying, okay, nuking the data all the time might be not the best idea. Yeah. So we have to do the database anyway. So, and we postponed it really. I mean, this is already a month later. And I'm saying, okay, come on. At one time you do, but just adding a database, it's not what happens. You use the database, and now you have to migrate the data. And what is keeping using a database if you don't do backups? Because so, and then you go into all the plethora of things we're saying, all those things go wrong, and you have to protect that stuff. So, but yet again, this is already a late stage of the product, so which really is good if you can push it. And again, if there is the database and you get more people and the product really starts flying, then you're saying, okay, but we cannot do it alone because we are also CEOs. We have also to do all the stupid stuff. So we need people in the team. So, and that's yet again team scale, but this time it's even more extreme because now it's 2-person backup, 2-person front end. And now you need to make the issue tracker, you need to exchange what needs to be done. You need to code somehow. You need, yeah, you come up with a development process, which is almost like pull request yes, no, and all that stuff you know pretty well. Then you, of course, you want to have not the image of developer A or developer B. You will have a building process that makes the artifact, which is reproducible. So you go in these, I mean, it's going professional, but it's also going annoying. So because that's already the things you don't want to do, you have to do, and that's always push it when possible. And then, yet again, what do you have to do? Is when there's more people and more people using it, and you do your backups and you have your database, what can happen? So if we talk about scale, and this is the product I'm representing, then we're saying right now we have almost 5,000 users. So that would be typical the thing where you say, oh, but now you need to scale up machines and stuff, and oh my God, you're becoming the new Facebook. No, we don't. And having 5,000 users, I mean, has anyone brave enough to estimate how many images we need or machines to make it? Huh? Yes. This is 5,000 registered users. Yeah. So if you make the numbers going from registered to active users, and then you know that one day has 86,400 seconds, and a week has 7 days, and then you do the math, then you say, okay, I need a lot of users until it gets really hard. But you still have to scale. But why? The one point every service is of quality is called resilience. That means if the operation of something is reliable. So we know all the services, you go to the website saying, sorry, broken, MySQL database not connected, cannot connect something. That's something you probably don't want to know, because even if you don't have many users, you don't want to lose them because you don't have that many. So if you're on a Google scale, you don't care. So it says a few thousand users less, I don't care. But if you go, and that's why the picture is more like scaling here. I like this one the most, because that's what it actually is. So what's the reasoning of making a resilient service? So it's easy. An image can crash. Yeah. So we are all perfect programmers. Yeah, but still. So blame it on Faro. Blame it somewhere on the moon or something. Images crash. Yeah. So sometimes you find a reason. Sometimes you have a hard way. But if the image crashes, the service is gone. Yeah. So what is the cure for preventing that? You need more images. Yeah. And you need 2 images. No, because if there's a load scenario and one goes down, what's the better condition for the other one? The same. So that's why you go from, you never go to 2, you go to 3. Because you have 2 images can compensate everything that has been lost when one image went down. Easy. But now you have more images and one IP address. So what do? Yeah, you need a load balancer. That's this tiny little thing that gives you one IP address, and that you can say, okay, shoot on all of these 3 or shoot whatever, and then these 3 appear as one. And that's a really good thing to do. You just install it on the same machine. There's nothing. So of course you have to do yet another Nginx, whatever, name the product, Linux, stupid configuration files. Everything you don't want to do, have to do. So are we safe yet? Of course not, because there's only 3 bullet points. So it's not only about images, because images are just virtual machines. The machine underneath can fail as well. So a user doesn't care if the firewall or the machine. If the service is not there, it's not there, period. And what could be the cure if one machine could fail to prevent that? You need more machines. Yeah, and that's easy. And you need how many? Great. Yeah, for exactly the same reasons. Yeah, but if you have more than one machine, you cannot put a load balancer on any of these machines. Because the load balancer needs to distribute among the machines. And if you put it on the one machine and you're unfortunate and this one goes down, ta-da, you're dead. So there's another machine. You know, you never go to one thing more. It hits you. The black hole is just having high gravity. So yeah, but the load balancer machine can also fail. So what do? Huh? It's maybe, I mean, you might see it already. You need a backup. So in this case, actually, it's an exception, because in most setups in a load balancer, one other one is sufficient. Yeah, because if you have 5,000 users, or what we have, the number of requests that go in needs to be 10,000 times more in order to bring a load balancer into trouble. So you could still say, make it 3. Yeah, but in this case, I would say exceptional. Well, let's save one machine. I mean, how many did we collect already? And then, yeah, you get, I mean, it's endless. So, and then you do, because the end is, hey, if I have more than one load balancer, who is load balancing the load balancers? And you cannot escape that rule. So at one point, you rent a hardware device from the cloud provider saying, the cloud provider has responsibility. This thing is up and this distributes, which usually works until you start using SSL, because then you have other problems. So you have no choice. So you get sucked into the whole. What we do in ActiveGrid is something which is called floating IP. It just means that we have 2 machines with the same IP, and in case of emergency, I can log in and just press a button, and then the other machine has the IP, and then so at least you can minimize the downside. But yeah, from all the components we saw so far, the load balancer is the less likely to go down. Yeah. Otherwise, well, except if the service provider shuts it down, that can happen as well. And this is all great stuff to do if you, I mean, it's not all bad. So the good thing about distributing services over multiple machines is there is no single way when you don't get an email that there's a Linux update. And none of us is likely to want to have all the exploits, to read all day the mails, the reports about new security exploits. So you want to do this. And if you have an infrastructure that you can switch from there, then you can always switch, upgrade one, switch back, upgrade the other. So at least there is something good. And I'm much faster than I thought. So we talked a lot about machines, and we know when you're going really, really upscale, then you have to have, I mean, how many machines did we get? 8? No, 5, 6? It doesn't matter, because if you don't want to log into 5, 7, or whatever machines to look for the log files, so you start collecting that at one point. Then you have the monitoring. Okay, that's the typical proverb says, if you have a service that's not monitored, you don't have a service. Because if you don't see if it's down, it's not there. Actually, it's something like the Schrödinger thing. And then you start monitoring. That means you need yet another service collecting data all the time from that stuff so that you can put thresholds or alerts, it's called. That if there's one machine not up, you can send, we do it via Slack, on a Slack channel, it's called maintenance. And if something happens, there's ding dong. And on my mobile, there is something like, if there's a mention on that channel, send me a push notification. So that is the things you can easily do if you don't have a $1,000 service to be paid. You can always chain all of that. So what is scale actually? So we went from the technical point. So the technical scale, that's the stuff talking about fast computer programs, distributed computing, or the Netflix stack, yeah, or some other stack, I don't know. But from a product perspective, I just want to repeat that you really need to, I mean, it's hard to do a product. Yeah, you really need to focus, and that's why you should just move all of that stuff away that doesn't pay into your product. Yeah, and then you cannot escape. So there is no, you cannot postpone for years. But then, so postpone to later is usually your product is more mature, and then it's more likely that you can invest the time into making that. So to me, when I try to reduce what I read on the internet and what I learn from life, is that when I read the internet version of when to scale is that you have the Netflix stack, yeah. So you have a thing that can scale, and that makes success. You have to say it in order to know that it's stupid. Yeah? So because the real version is just the other way around. So usually you don't need scale until you have some success. Because all the performance, all the stuff, you need users, you need a pressure putting on your system until you need to scale. I mean, all my machines, I'm not sure how many we have right now, they're all idling. I hope that there's someone, I mean, we have virtualized computers for the reason because others can use the CPU cycles we don't need. Yeah, we just have the shell that's saying, if someone wants something, we are open ears. But to be honest, 5,000 users, I mean, the most we get is 15 requests per second, which is, let's check, 2024. It's not a number anymore. So in the 90s, this was a number. You could not barely stand when CPUs was 200 megahertz. Yeah. So, but nowadays, I think that you can have one or more zeros put in the end. So the conclusion to this, and I started the clock at the wrong point, is scaling distracts you from what you want to do. So always have that in mind, that everything that is not business related is distraction. So I'm always talking to people saying, Kubernetes is a super system that you can put interest if you're not interested in the problem your company tries to solve. Yeah. So so there is a technical aspect. So okay, my company tries to do a good service, but come kill it. I do Kubernetes. Yeah. So from a product perspective, this is really poison. Yeah. So you need to really focus, and it's hard, and the money doesn't grow on tree, at least not in Germany. So this is not the way to go. So, and that's the rule saying, when you change the system to gain something, I'm almost sure you lose something. And people always talk about gains. Oh, we changed that architecture, then we have. So you saw, I had my computer, then I had to put someone on the network. I'm already losing something. Then we have installed it. We have to use Git. We have to do Jenkins. You always lose. And you have, when you're saying we are doing something to have a gain, you're always saying, okay, I know there's no gain without having a loss. And then you say, but what we are losing? And then you start weighing, yeah? And then the rule is just, when the benefits outweigh the drawbacks significantly, then there's a good reason to scale, yeah? And if not, then not. So I think in my life I was, especially in the Linux sector, I was caught up. Every one of us gets caught up in these technical stuff, and then you focus, and it keeps you concentrated because it nearly works, and it nearly works, and it nearly works, and yeah, tomorrow I try again. It nearly works. So, but yeah, in the end, you know, I just should have stopped 20 minutes after starting that. Yeah, because the time would have been better spent somewhere else. So that's already it. It was a trial giving a bit of insight how we, and we did it really. That's not a made-up story. So we really did it that way, and I can really say that's for us. I mean, it's hard enough. You have to have all this technical shit, but really that worked for us pretty well to make it as lean as possible. And yeah, so that's the last slide. I'm not sure. Oh, it's 2 minutes early. So that's it. I thought I'd do something less technical this year. I hope you enjoyed it a bit. Is there any question? Ah, Nuri. Oops.
Also a question from my side, Norbert. Going to putting things on a server, because you're very maybe even an expert in Linux. Yeah. Were you creating scripts and things to automate so the process was easy enough? Because is that something that works for you or did work for you?
What exactly?
Well, that you explain like, okay, I have to copy a secure copy an image, then I have to log in with a secure shell and then restart the image. But a number of these things can be automated a bit more, of course. So how? I'm assuming you did that.
I mean,
if that,
but yeah.
So if you did that, did it help? Is that the way to go? Feeling that in a way I'm still at that level at the moment. So learning from you.
Yeah.
Would that be the way to go?
No.
And did it work? Oh no.
No. No, that's the thing. And each scale level, a different thing is good. So this was good not to being distracted by copying, but of course you copy it manually. Yeah. So okay, this is almost this one line you can copy. You don't make an error. So automation is about two things: is having a complicated stuff in order and fail safe. So you don't make this manual human stuff is always like, oh, I typed an R for an L, blah, blah, blah. No, it just works at the beginning. So, and for us, there would be another story because at the time you have the CI. So when you have a development process and you decided, so we want to have everyone talks about continuous integration. Yeah, so we want to do that because if some pull request is merged, it's built, tested, and directly installed on our alpha stage. And then you have a deployment script scenario, which gets really complex. Because then you deploy it in that server, in that version stuff, and then it gets also complex. The good thing about it is that I'm getting an old grumpy guy, but all my thing is that most tools I discovered in my career suck. And there's only a few that don't, and one is Ansible. And that's the one where you can describe all your stuff, and it's a Python base, and you have to care with YAML. But that really works good because it does it exactly at the level of complexity that it covers. So you can really manage, and I do it by hand on my computer, just saying here, new product release, blah, blah, blah. And then it runs all over the machine and blah, 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 and makes that. And we even make a zero downtime deployment, which just makes, we have 16 images on one machine, and then it takes one off, another one, but then the other comes up, and the load balancer just reroutes you to other Faro images. So we do sometimes release it 3 times a day, because you just have the next thing, oh, I forgot this front-end release, blah, blah, blah. And then you just say, okay, it's the next version. And then you start it, and then it just goes and installs all the stuff. And the same script is used from the Jenkins server. So when the back end and the front end were copied in the integration build, integration tests were running, a Docker image was built and uploaded, and then this script is used to pull that Docker on all the machines and install that. So, but that would be a calculation saying, and that's what justifies complexity is the amount of time it would need me to reliably install something on the machine will take minutes every time. And this thing is nothing. Sometimes I'm just saying lunch. Okay, let's just start at the release deployment and go for eat. Yeah. So that's the other. That would be another story that you can really make the calculation. You say, you can. The proverb says, you can save 10 minutes of work by coding 3 weeks. Yeah. So and that's it. So you have to do the calculation, saying, do it the manual way until it either gets too annoying, or if the whole thing consumes more time than the expected outcome of doing that. Because something then you can say, when nobody does that, saying, hey, we're saving 10 minutes, 5 minutes, 10 minutes. And if you do the calculation, at the end of the month, you sometimes have a whole day. And then you so you have to match it. And that's, yeah. I understand that you just don't want to go the route yet to learn yet another tool. But yeah, you have to weigh. At the beginning, yes, and no.
Yeah. Thank you. And also thank you for another piece of technical issue.
Yeah. Come ask me. I suffered for you the last 30 years.
If I understand correctly, you do run your own servers on your own premise or in warehouse.
Yeah.
But in a scaled-up version, there are some technical things which, like 99% of applications in the world need. So, did you also look into cloud-based solutions that also does this technical stuff for you, which you apparently have made yourself with Ansible and etc.?
Well, I'm not sure what you're targeting. So, cloud provider, which choices you have? Either you hate Linux and then you get sucked up into Amazon's thing, which is way bigger. Yeah. And the other thing is what you really want to do. If you want a Kubernetes, I won't do in my whole life because that's such a shitty
No,
piece.
it's too complex.
Yeah.
I mean, more like an application supportive
application
service
provider.
on a higher level.
Yeah. There exist, but I never heard really good things about them. So what you want is to have your pod, they call it, or something. You want to have someone that allows you to upload that thing into their Kubernetes and they manage it. Yeah, so that's another level. But well, in the project before that, I just did it with Docker Swarm. You can check the Cagliari presentation about microservice and stuff. And there I just I'm a network expert and stuff, and I really see using Docker Swarm Kubernetes. So my theory is you have a fishnet. Yeah, and what you scale is the hole. And if you go with that, the hole gets bigger, and then you have all these technical problems that fall through the hole, you're out of business. So this is just something, there's a few things that you really have to do yourself. And so I'm an old guy. I use Ansible and a lot of scripts and I'm on Hetzner and stuff, and I know it works. So,
But I think it helps because you're a network expert that
Exactly.
you can do more of the technical things yourself more easily if you make the trade-off in how much time it costs.
This is far from being a general advice. This is me.
I get it.
Okay.
One technical, one non-technical. Okay, the first one. What is Active Grid about? So what kind of service is that? And is it a public service or something? What is? And the second is about, you said you had zero downtime in migrating to versions. Do you have? I think the session will go. The user session will be lost. So there's this. Or do you have something about session transfers if you migrate to another server or have to take down a server?
Okay. Active Grid, for those who don't know, is, well, you could say it, low-code or no-code platform. So in the last 30 years, or in our business, we just checked that most of the IT backend stuff is just repetitive. Yeah, and IT tends to be complicated, expensive, time-consuming, and everything. And our platform, you can model your database, your data model, you can model, and we have workflows where you could put the behavior. So for most small to medium-sized business processes, you can just click them in a few minutes. So we enable companies to do that without, spending a lot of money and a lot of nerves. And we talk to the one with the problem, not usually with So the second part was zero downtime is, the good thing is I'm an old guy. I've seen things. And the one thing I don't want to do in such a backend is session state. So the backend is stateless. Stateless, for those who do not know, URI is a description of it's opaque. Of course, it's kind of an object handle, like a reference, but it's opaque in its usage. But what it contains is that if you put something stateless, that every state you need to do the computation is included in the URI. And that is what we strictly do. So there is no session state. There is, and then if you learn from Google and HTTP, then you know, you make it complicated. It says to state no session, yeah. And then there is these points where you just put a little cache and you're way faster than anything else. So it's a kind of architecture. So we don't need this. So I avoided that from the beginning. Sessions are bad, yeah, depending on what you do. And so we can just pull. So the load balancer just saying, you go down, I try it 3 times. If you want to cooperate, I take this one, yeah? So that the only thing you will notice is that your request will probably take a second longer. So while we switching that, but you won't see anything else. It's an architecture decision. Okay. Oh.
Last question.
No, he stole my question. I will give it back to you later on.
Thanks. Thanks, Norbert, for the talk.
My pleasure.
I would sign almost everything you said. I would even like to add, sometimes you have to weigh in how catastrophic is it to lose a user session for 2 minutes if I have to do an urgent update. And I would also absolutely sign that you have to reduce complexity as long as you can. So learning Kubernetes or Docker or whatever is not needed for the first, I don't know, 3-4 years. And yes, you're extremely successful. And I found that rsync and bash scripting and secure copy are such powerful tools. And you have to understand the tools for catastrophic cases. I mean, you have to understand your whole system. Somebody has to be able to redo the thing in a day or something. So be careful about adding too much craft onto your technology stack. That's extremely important.
Yeah.
So yeah, it's not a question. Sorry for that.
Yeah. But if you don't know the things, you're lucky. It's like lottery then. So I mean, we call it in small talk. I mean, it's the one system where it's the easiest to get yourself in trouble, but it's the only system where you get yourself back out of trouble.
Yeah.
So so yeah, knowledge is king.
Thank you, Norbert.
Thank you.